All right, let's get started on our review today. So, of course, don't forget that we have lab finals this week. So, I expect to see y'all today for lab final and checkout. And so, this one just is weighted as another lab. So, same weight as a lab. So, again, make sure that you are turning everything in. I'm a little concerned. My grading felt a little light over the weekend. I kept kind of checking for missing piles. So I'm expecting fat stacks, and Thursday again is, I expect everything in by Thursday, and I'm generally very generous, so you can probably still email me up to, 11:59 on Sunday or whatever, something like that. So yeah, but the sooner the better. That'll make me happier. So just continue to turn everything in. I have no idea how the grades will shake out. I've already expressed that there'll be some sort of curve. I would not depend on a curve though, so just again attempt to perform your very best on the final. So the whole point of the rest of the chem grades is supposed to boost up your final. So the labs and your homework, that's all supposed to be free cushion. So again, make sure you turn that in. And don't forget about those reading questions. A few people have a lot of blank reading questions. I believe that's worth 10% of your grade, right? If I remember correctly, your reading questions. And so again, your grade is not weighted on Blackboard, so do not just take your score divided by the total score that it tells you. That is nowhere near an accurate representation of your grade, right? Blackboard is unweighted. I do everything manually, separately, so I will later input a manual what your final grade is that I will import on there, but Blackboard will never be correct. I will never calculate your grade using Blackboard. All right, any other questions, comments?
I did have, I sent you an email. Can I ask you after class about accessing some journal articles?
Oh, yeah, I just didn't respond to you. I'm sorry.
That's okay.
Yeah.
I just didn't know if you'd have time or if you needed to go set up for the final.
No, I set up this morning for the final, but during the final is a good time I can try to get articles to you.
Okay, sweet.
And yeah, I think you're the only person I owe articles to, but if anybody else needs journal articles, email me and I'll get those to you or try to. Uh, oh, did you email me? Okay, email me. Okay, good. Email me. I was thinking, I don't remember. So yeah, just email me. And I know a few of you have also emailed me about grades that are missing, so keep doing so. I'll try to fix that today and just kind of keep pestering me. Keep an eye on your grades until everything is accurate. And then, like I said, I should have everything graded. I graded the quiz from last week. I just didn't put it in, so I want to get that back to you. But take all your stuff. I do not want your stuff. You guys need it for your assignments. And yes, the lab final is open notes, so you will want your labs for that. Or you could reference them on Blackboard, and I can post them on Blackboard if they're missing. All right, other questions, comments, watching the chat? All right, so let's just start doing some review questions. And so, of course, you want to be quick with some of the multiple choice questions. And so I would expect to see something like this. 2 different styles. So I think you had the bottom one on your quiz. So how do you approach these? So which sample has the greatest number of molecules? So 5 moles of helium, 5 moles of argon, 5 moles of krypton, 5 moles of xenon, or all the same. And then compare it to the wording in this one. So each one has a mass of 10 grams. So which is the greatest number of atoms? So take a minute or two for that one. We'll go over it. And again, if you have other questions, happy to deviate. I do have a prepared review.
Is it possible to do more practice questions for like the heat problems? Like,
Yeah, we'll do some heat ones. So yeah, so let's keep it moving. What's the answer for this one? So what's the answer for the first one? Which one has the greatest number of molecules? So what do we?
somebody say it.
What did you say? E? So all the same, right? So trying to trick you with this one. So again, just watch your units at all times. So moles. So obviously same number of moles, same number of molecules. Good. And then this one, again, this was from your quiz basically. A few people fell for it though. So right, we had a mass of 10 grams. You didn't have to divide by everything. So what's the trick? So lowest molecular weight. And in this case, right, that leaves us with helium then for our lowest molecular weight, or whatever the appropriate answer choice was. All right, good. So let's try, this is going to be just like your exam, except like I said, it might be symbolic on your exam as opposed to friendly chemicals. So I'll write out our problem. You know, X's, Y's, Z's, symbolic.
I didn't hear symbolic.
Oh, sorry.
Else. I was like, what is that?
I don't want to know.
I missed that a little bit.
All right, so this is what you would be given on an exam. So given this reaction, so we're doing a bromination reaction of ethylene here. And so adding bromine across this double bond, like shown. And so you can compare the structure. And so given the following bond energies, so you're given the energy of a carbon-carbon double bond, single bond, your bromine bond, and your carbon-bromine. So figure out the overall energy of the reaction. And then with that, you can also tell me, of course, if it's endothermic or exothermic.
us the H formation values. I didn't see the CO2. You said it was like special when you did it in the lecture, but it didn't say anything special in the book about it.
Mm. But yeah, I would like give it to you on the exam.
Okay, you will.
Yeah, like just like this. Like this is how it would be.
Okay.
Do we have answers? Are we ready? Is it relevant? Hmm? Do we make or break any carbon hydrogen bonds? All right, we'll keep the review moving. I just want to do a lot of problems. And so just kind of going over it. So again, bonds broken, endothermic, and then a question came up both in the chat and in person, but then it was kind of solved, right? So looking, no, we don't actually need the CH bond, right? Because we did not make nor break a CH bond. So that's why it was not included. And so, okay, so let's see what was broken. So what was broken then? So our carbon-carbon double bond, and then what else do we have to break? So bromine-bromine. So good, so 611 plus 193, so we could do, so 804 kilojoules, good. And so now let's see what we get back out as exothermic. So again, bonds formed. And so now we got back a carbon-carbon single bond of 348. And then 2 carbon-bromine bonds. So don't forget the 2. That's why it's always good to draw it out. And so what do we get for this one?
I got negative 96, but I'm not 100% sure if it's right.
Yeah, it sounds. Well, it could be negative 96 overall, right? Is that what you mean?
Yeah.
Oh, okay, yeah.
That is what I meant, sorry.
Sorry.
I just did the whole thing on the thing, sorry.
Yeah, so that sounds right. But let me catch up to you. So 276 times 2. So then, yeah, so negative 900 plus 804 would give you negative 96 kilojoules, just as stated. And then, so negative, is that endothermic or exothermic? So exothermic. And good. Questions on that one? So like I said, that's almost straight from your exam. So let's do, so now we'll do another one. Sorry, I'll start a new page for this one. One of the Hess's law type questions. So we're trying to figure out our heat of formation. And so this is our equation. We're going to figure out our delta H of our reaction here. And so this is what we are given. So C2H2 plus 5/5 equivalent of oxygen gives us 2 CO2 and H2O, and that has a change in enthalpy of negative 12, 99.5 kilojoules. And then, so carbon plus oxygen gives us CO2. And that has a heat of formation of negative 393.5 kilojoules. And then the last one is hydrogen plus oxygen gives you water. And that has a heat of formation of negative 285.8 kilojoules. So how do we get to our desired heat of formation? All right, what do we think for this one? How can we manipulate these equations 1, 2, and 3 here? Any thoughts? So that's, yeah, that's part of the trick, right?
Oh, I didn't see it in there, sorry. I just didn't even get
Oh, no, you're fine.
off in the distance.
But what about this first equation? What might we want to do to this first one here? So flip it. And right, we can come to that conclusion since we're looking at the C2H2. And so we want it on the product side. Right now it's a reactant in our series of equations, right? It's nowhere else. So yeah, that's a pretty good assumption to flip it. And Chad agrees. So let's just try that. So H2O, I'm just rewriting it. And then I am going to go ahead and flip my sign so I don't forget. So now it's positive 1299.5. Okay. So let's kind of look at this. And now I'm just trying to figure out how else they could cancel. Like I might want these CO2s to cancel. So what should we maybe do to this equation too? So multiply it by 2. So let's see what that does. So 2 of our carbon plus 2 equivalents of oxygen. Oops, sorry. Give us 2 equivalents of CO2. Good. And I won't plug this in right now, but I'll just put times 2 so I don't forget. And then what about our last equation here? 0.8, the negative 285.8. So what should we do to it? So just added it. So let's look at that. So H2 plus O2 gives us water. And so now let's just start crossing out everything, double checking, making sure that it adds up. So again, I'm just eliminating whatever is the same on the products and reactants. So reactants, products, eliminate. Okay, so let's see. And I'm just seeing if it adds up. So we have 2 carbon plus, and so, okay, 2 plus 1/2, so that does give me 5/5 over there. Let's see. So this should cancel, right? So you see how your oxygens cancel. And so that does leave us with what we want, right? So 2 equivalents of carbon plus my hydrogen gives us C2H2 there. So does that make sense? Adds up to everybody? And so now we can just finish adding our values off on the side. And so let me plug that in as well. So 1299.5 plus my negative 393.5 times 2, and then plus my negative 285.8. Oops, what did I do wrong? There we go. Okay, forgot all my plus signs. All right, so then did we all get this number? Yes, no? Okay, so I see lots of yeses, so good. So now this is 226.7 kilojoules for this process, and then obviously endothermic. Any questions on that one? All right, I'm going to switch back to another problem. So if you want more thermodynamic questions, let me know kind of what style, and I can put them back in. Let's switch for now. So let's just try this one. So this is a common technique in chemistry. So some sort of precipitation reaction. So you can measure out a variety of metals by this method. So in this case, we're looking at iron by precipitating out iron sulfide. And so we want to figure out how much iron nitrate was in their original sample. So if they reacted iron to nitrate with excess sodium sulfide to produce 12.34 grams of iron sulfide. So how would you calculate that? Yeah, so you can go ahead and start to work on this. So yeah, this is right how it might be given. So just like she said, first thing you want to do, what's your balanced equation? Figure it out from what you're given. So how is this one coming along? Walk me through it. So what's our balanced equation?
Take a break.
Someone's ready for the final.
Maybe. Some things.
FeNO3 2 plus NaS FeS.
Yeah, Na2S, and then, yeah, it gives you good FeS plus 2 equivalents of sodium nitrate. So does that look good? Is that where everybody started? So right, needed to start here. And so this is what I'm saying. I probably am not planning on testing y'all explicitly on naming. I mean, maybe one will slip in there, we'll see. Also, no one is taking the final early, right? Because the only person that has talked to me is taking the final Friday, so I'm still kind of playing with my exam. So again, if you want to take it early, let me know ASAP so I can officially print it and send it. But yes, expect to be tested over naming right in this manner, so you're not given an equation. So okay, so now we have to figure this out, and now we can do the stoichiometry. And so then what do we get for our molecular weight of iron nitrate? So these are other, right, good freebie points. So setting up all your knowns, so calculate your molecular weight. That or iron sulfide. So what's the molecular weight of iron nitrate? 179.8 what? 4950, something like that. Again, small discrepancies. And then what's iron sulfate roughly? 87.91 grams per mole. Excellent. So now we can set up our stoichiometry. So backtracking. So we were given iron sulfide. And this is why I say, right, set up your kind of your knowns over here with your molecular weights. And now plug in our molecular weight for iron sulfide that we calculated. So that gives us moles. Then we look at our mole-mole ratio. So luckily they're in a 1-to-1 mole ratio. So for every 1 mole of iron sulfide, you get 1 of iron nitrate in this case. Again, just reference your balanced equation. And then it didn't really say if it wanted this in grams or moles, so you could have stopped here and gotten the molar amount or multiply by the molecular weight if it had specified. And so let's just punch through it. And so we get, right, 0.14 moles of it. Again, 1-to-1 mole ratio. And if we wanted our original gram amount of our sample, so then we would have 25.21 or 0.2 roughly grams. Questions about that one? Yeah, because this one didn't specify, but probably on the exam I will say, but yeah, this was just a loose scenario. So yeah, just answer the question. I'm not too picky on that. Let's practice our Lewis dot structures. So see, we can do bromate and IF3. So practice both of those. So bromate obviously has a -1 charge on it, and IF3 is neutral. And include any relevant resonance structures and formal charges for these.
bigger, they can like take on more than the
Yeah.
right? So should I be putting the BR and the I in the center?
Yeah.
Both of those things. Okay.
Yeah, so BR and I go in the center, and then see what you can do from there. So how are our structures coming along? Let's see. So let's see how we're doing. All right, and so remember how to approach these problems. So first we have to see how many electrons we're bringing to the party. So 7 from bromine, each oxygen, right, has 6, so times 3. And then the negative charge means that we have an extra electron. So let's see, so 8 plus, so 6 times 3 is 18 plus 8. So that's 26 electrons, right? Doing really bad mental math recently. All right, and so now that we have the correct number of electrons in our party, so now we can figure out how they go. And just as was stated, right, a good starting point is just literally drawing a line to each one. Okay, so now we have 6. So now we need to fill in 20 roughly. So 1, 2, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. All right, so this is one structure. And so let's double check a few things, right? So again, we have to do our formal charges as well. And then we want to make sure octet rule is satisfied. And so formal charges, what do we get for our formal charge on our bromine? So what's the formula for formal charge? Do we remember? So remember, formal charge we can calculate. So I say the number of valence electrons, right? So from the periodic table, then minus the number of bonds, and then minus the number of individual electrons. So looking at bromine and calculating that, so 7 for the valence electrons, again that's just from the periodic table, minus 1, 2, 3, minus 1, 2. So what does that leave us for the formal charge on bromine? So 2 plus, And then if we do the same process for oxygen, and they're all symmetric, right? So in this case, it doesn't matter which one I pick. So 6 minus 1, 2, 3, 4, 5, 6 minus 1 bond. So that gives me -1. So that's a -1. All right, so now this is a correct and valid answer. But as might be expected on the exam, I'm going to say include all valid resonance structures. And so the key point, again, is to understand how to analyze the structure, right? Like, I don't expect y'all to just know things. Oh, yeah, this is how it goes. I obviously know there's a single bond and a double bond. No, right? You need to go through the analysis. It's supposed to be a process. And so that's what this process tells us, that, okay, I have a 2 plus charge next to a negative charge, and I have another charge next to another negative charge. So I can probably make some double bonds here. And again, right, you can play with it. Bromine can go hypervalent. So obviously we're going to have some issues. So if we make 2 double bonds, that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for bromine. So pretty hypervalent, but still okay, right? Still a valid resonance structure. You just want to show that. And so that is, again, just a process. So maybe you want to just make one a double bond first and then show that structure. So all I did was turn one into a double bond. So obviously that makes bromine technically hypervalent. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with how I've drawn it. But now we've minimized some of our formal charges. So 1, 2, 3, 4, 5, 6. So this still carries, right, a +1 charge. And so that's why the argument for maybe making 2 double bonds makes sense. And again, just showing it, playing with it, showing that you're kind of aware of these possibilities. It probably is going to have somewhat of a short bromine oxygen bond, right, if we were to look up the crystal structure data for it, because that's where we would go next, right? So we're kind of making these predictions. We kind of expect there to be this kind of double bond character. That's all that we're getting at. And so now we can show this resonance structure. So 1, 2, 3, 4, 5, 6, 7. So now we finally minimized our formal charge here. So no formal charge, no formal charge. So we still need a formal charge, right? Because our whole bromate carries a -1. So I expect it to have at least one -1 formal charge on it. And again, right, you want to emphasize that negative charge is always on the oxygen rotating around, right? You can move these double bonds around and kind of show those structures. So obviously, right, I could have switched the double bond. So you're just showing, right, all these are the same. And again, right, with the resonance structures, we're not changing the connectivity or anything. We're just moving around that second pair of electrons to show electron density and how it may be, right? So again, we're just showing there's probably some double bond character, right? And again, you're going to see the electron density rotate around and be centered around that oxygen with some double bond character. So they're different, right? So we're trying to show that like the double bond, that the density is rotating around, right? Because you want to show that it's like evenly kind of rotating around. So yeah, so it's not just like a rotational argument, although, right, that is also valid in chemistry. But yeah, in this case, we're keeping the molecule itself stationary and then just moving the electron density. Other questions about this one? And then again, is that like clear what a complete answer is? So you want your electrons to be correct. You at least want a few of these resonance structures, right? I'm not going to expect that you do every single one that's mathematically possible, but at least show a few, right? I want the idea that you can have single bonds and then these double bonds kind of rotate, and include your formal charges, again, for full credit.
So the formal charge, the equation you have up there, it was the number of valence electrons minus the number of bonds minus the lone pair electrons?
Minus each individual electron is how I count it. So like each one separately. And I only say number of electrons in case you have like a radical or something weird where it's not even. Does that make sense? So yeah, you count like the individual electrons on an atom. And yeah, usually they're an even set. I haven't showed you any radicals. Uh, not strategically, yes or no, I just haven't. All right, so what did IF3 look like? Should be a nice looking structure. So iodine in the center. How many total electrons are in this system? Valence electrons. Say it loud. Some of you are like whispering it. Gavin, what'd you get? Yeah. Whispering over there. So 28 electrons. And so again, right, that's where we need to start. That's our perfect starting point. And again, just start drawing a line out to all your fluorines. And now fill in your electrons. And so that's all I'm doing so far. Starting with my fluorines. So 8 times 3 is 24. So now 25, 26, 27, 28. And so we do get the correct structure of this. And we don't need to know the geometry, but I just can't help it. So it's T-shaped. Like I said, you're not going to be tested over that. So no geometries this exam. Like I said, I can't help but lay the groundwork for next term where we are going to name our geometries. So just trying to get you to see that. And then our lone pairs, right, coming out. So basically this is in the plane of the board and then lone pairs coming out, right, in front and behind there. And then no formal charges, so everything looks good there. Iodine is hypervalent, so you probably want to call attention to that. So 10 valence electrons on iodine formally. And so yes, hypervalent, but yes, that is okay. All right, should we take our quick break here? All right, let's take a quick 10-minute break here. And I'll prepare more questions. So ask me questions too. Or let me know what type you want to do. So yeah, there might be like some questions about resonance or like kind of like on the quizzes where do any of these display resonance? So yeah, that could be on there. All right, let's try to do a few more. So let's start with this equation. So you'll probably see these in multiple choice format. So using Hess's law, determine the heat of formation, or the change in enthalpy, excuse me, for this reaction of C going to B. So what would the answer be? So take a minute or so, and then I'll pull. So what's the answer for 7 here? So you want C to B. So what do we have to do? What do we need to flip? Huh?
That one. No, you have or not.
So flip the bottom one. And what do we get? A. Who thinks the answer is A? No votes for A. B. C. I would double check yourselves.
I think it's
Or
A.
do-
I did. You gotta flip the sign, right? If you flip the.
yeah, but where's the rest of the class?
I also wrote down C though, and then I'm like, wait, I didn't do that right.
All right, so what do we need to do for this one? Which equation do we flip then, right? So yeah, easiest to flip the second one. So now C to A, but then we have to flip our sign. Okay, good. And so the A's cancel. That does give us C to B now. But then 30 plus 10 kilojoules gives us what for our answer? So 40. So A, good. Questions? And then, so now look at 8. Remember, 8 is another one of those terminology ones. So read through it. What is it saying? So a system absorbs 15 kilojoules of heat and does 5 kilojoules of work on the surroundings. So what is the change in internal energy? So I see the chat has an answer. So, okay, if a system absorbs 15 kilojoules, what's my sign on this? Positive, negative? So positive, right? So plus 15. And then does 5 kilojoules of work on the surroundings. So is this positive or negative? So negative, right? Because our system is doing work. So plus by negative 5 kilojoules. So what does that give us for our answer? So B, excellent. So you'll probably have a question like that. All right, so try this one. And so now we're given our standard heat of formations for the following substances. And we're given this reaction. So 2 equivalents of sulfur trioxide decomposes to give us 2 equivalents of sulfur dioxide and 1 equivalence of oxygen. So how would we solve that? Oops, sorry, that's not good. All right, do we have an answer for this one? What do we need to do? So we have our formula, right? Our change in enthalpy. Oops. So change in enthalpy is equal to the sum of our change in enthalpy of our products minus reactants, roughly. And so let's do our energy of our products. And so just double check my numbers for me. So 297 times 2, since again, right, we have to go by the molar equivalents, and then oxygen elemental form, so 0. All right, so products now minus our reactant, so 2 times our negative 396. And so now I get positive 198 for the answer here. And chat agrees. Do we all get that as well? So it looks like the answer is A, positive 198 kilojoules for that one. Questions on these? So let's try this one. So you had one on your quiz that was pretty similar. So which one of these is a non-electrolyte? So what are you looking for in these types of questions? What's the answer? So what type of substance is a non-electrolyte, generally speaking?
Something that doesn't release ions into solution.
So something that doesn't disassociate, or, right, a molecule. And so all of these, so this is ionic compound, right? This is a strong acid that disassociates. So which one is our non-electrolyte here? So D, ethanol there. Good, and I see chat has that as well. Let's see. Let's see if you can try this style of question. So which pair will experience the strongest Coulombic attraction? So what are you looking for? So what's the trick with this one, right? We don't need to calculate anything, but kind of what are we looking for? What increases Coulombic attraction, right? So what does? What leads to increased Coulombic attraction? So the charge, right? So now we're looking at our technique. So yes, we're looking for our highest charge. And what else to balance that? And so atomic radius, so do we want it to be small or big? So small, good. So small radius, excellent. And chat has that as well. So now let's see that. So which one has our highest charges, so not the sodiums, and our smallest distance, so that leaves us with A there. And so again, expect this type of question, so I don't need anybody calculating it. We're just looking for greatest charges at our smallest radius there. Excellent. Let's try one of our solution ones again. So multiple choice style. And then pay attention, we'll go over this because I'm not sure we went over it well. But what does it mean by added? So how much water must be added to dilute 5 mils of 8 molar sodium hydroxide to 1 molar? So what's the key point there? And so just going over this one, so C1V1 equals C2V2 for our formula. And so, okay, so now we're trying to figure out, so 8 molar, and we have 5 mils. And so we want 1 molar, so we need our new volume. And so let's just calculate what our new volume is. So 8 times 5, so that's 40. divided by 10. Or sorry, divided by 1. So we get 40 milliliters, right, total for our V2. But then it says added, right? So now we're thinking about how we're going to make it. So if our final volume is 40, though, so properly you want to use some sort of volumetric, that's 40. But then we take our 5 mils and then add to it. So what do we add to it? So 35, and answer was in the chat. And so yes, you would technically add 35 mils of water to dilute it to your final volume of 40 that you found there. So just watch that with the wording when you see these dilution problems like that. All right, let's try another style of question. So now if we have a 1 molar solution of sodium hydroxide, and it took 15.78 milliliters to neutralize 2 milliliters of vinegar. Then what is the concentration of vinegar? And I want it in weight per volume, grams per milliliter. So how would you solve that? And I would probably at least tell you that vinegar is monoprotic if I don't give you the formula, but that's actually I'd probably have to give you the formula for vinegar. So C2H3O2H. So that's vinegar. All right, how's this problem going for us? So first of all, right, we need to write our balanced equation. So did we get to that? And so I try to give you a hint of it being monoprotic so that you would know that it's just a 1-to-1 ratio for acid-base neutralization reaction. And then this gives you C2H3O2Na, or acetate, sodium acetate. That's what that is, right? Ionic compound now. So we have our formula, or at least, again, you don't need to write this, just recognize that they're in a 1-to-1 mole ratio, base to acid. And so then that means, what should we do for our first step? So moles of NaOH. Excellent. So we were given a 0.1, so that's moles per liter solution. And so we had 15.78 milliliters, so converting, so 0.01578 liters to give us moles. All right, so then we get that many moles, so 0.001578 moles of sodium hydroxide. And then again, 1-to-1 mole ratio, so that means we have that many moles of vinegar. And so then at this point we could find probably grams of vinegar. So what was the molecular weight of your acetic acid? So adding it all up. So 60.05 grams per mole, something like that. And so then we can find either moles, or actually we didn't have to do, oh yeah we did, sorry. Got confused myself. So times 60.05, so that gives us grams. So 0.0947 grams of vinegar. And then I had requested it, at least the question, in this weight per volume format, and I tried to give a hint of grams per milliliter. So all I wanted for this answer is that you take the grams you found it, so 0.0947 grams, divided by how much vinegar we originally started with, right? 2 mils of vinegar solution. And I wanted to know how concentrated is that vinegar solution. And again, weight per volume percentage. And so times 100 to get it as a percent, and we should get about 4.73%. And again, you might want to put weight per volume just so we're clear. And again, right, this is a very common unit of measurement. You can see it on different substances like, you know, alcohol or maybe isopropanol, right? Everything is some sort of percentage, and then it's a question of whether it's weight per volume, or sometimes you see volume per volume, so that'd be percentage of a volume, right, where everything's in a volume. So fairly self-explanatory. Yeah, so this is grams of acetic acid over how much volume of acetic acid, because we're trying to figure out, right, like how concentrated a vinegar solution is. Yeah. Yeah.
Just so I have this stuff right, like balance your equation, convert your neutralizing agent to moles.
Yeah.
Compare with how many moles it reacts with your acid or base. And then I think I missed the next part because I was.
Oh, and then so once you get the moles, we solve for the molecular weight, so then we can just multiply moles times molecular weight, right, to get us.
Convert back to grams.
Yeah, so just getting back grams. Since, like I said, I wanted a weight per volume in the answer. And then, so we might practice another stoichiometry problem. But just in case we don't get to it, right, think of other types of questions that might be on the exams. We might have some time for multiple choice practice, but identifying reactions. So that's a big one. So, right, precipitate reactions, or maybe even identifying the precipitate. Precipitate, sorry. Can't spell. Redox, we haven't done that yet in review, but right, identifying a redox reaction, or maybe oxidizing agent, reducing agent, or some sort of thing, right? So some sort of oxidation states, or identifying oxidation states. So all that is fair game. Also terminology with thermodynamics. So there's a lot of definitions, terminology. Oops, I can't spell terminology. Right, definitions. So look up the definition of a state function and work and all that. So know your definitions. Oh, guess my camera's frozen. Oh, my poor. I don't know what happened. All right, let's do. I'll try to fix my camera in a second. Oops, did not want to launch Xbox. Sorry. Oh, go away, go away. What are you doing? Sorry. So let's try this stoichiometry problem. So now 2 equivalents of copper chloride react with 4 equivalents of potassium iodide to give us 2 equivalents of copper 1 iodide plus 4 equivalents of potassium chloride plus iodine. And so let's do 50.5 grams of copper chloride are reacted. And so I want to know how many, let's do moles of iodine are produced. And let's do mass. And then if I recover 36.7 grams of iodine, what's my percent yield? So how would you approach that question? Sorry? Yeah, sorry, mass of iodine. Okay, camera should be back.
This is mostly calcium chloride, right? That's not a U or a base. Copper?
Yeah, these are all CU.
Oh yeah, that makes way more sense. I don't know why I wrote it. I did not sleep, my brain just.
Okay, how are we doing on this one? So kind of walk me through what information do we need. I see chat has an answer there, which looks pretty good. So walk me through the setup. So what do we need to calculate? How do I get moles of iodine? So we need moles of copper chloride. So what's my molecular weight for copper chloride? (134.36) or something around that. So let's just set up our stoichiometry. So what we're starting with, so 50 grams divided by the molecular weight of copper chloride, so about 134.4 or so. And then going back to our balanced equation that we're given, so for every 2 moles of copper, we produce 1 of iodide. So set that up. And so then what do we get for this number? I'll punch it out. What did you say? Sorry, I didn't hear you. Yeah, so how many moles? And then divide, yeah, so copper and then divided by 2. And so what do we get? So 0.19, so 0.188 for the chat here. So something like that. Let's see, probably want to keep 3 sig figs at least for our mass. All right, good. And then, so then I asked for the mass of iodine. So of course we can just take our 0.88 moles, multiply it by our molecular weight of iodine, which I have it as 253.81, something like that. So I see some yeses. And so now, again, make sure you're using I2, since it is iodine the molecule. So then I get 47.7 grams, which that's what chat got. Do we get it in here? So I see some yeses. If you don't, ask questions. And then, so this was one that tripped up a few people on the last quiz. Hopefully I handed back the quiz to everybody who took it. And I apologize, I labeled this last quiz as also quiz 5, so you have 2 quiz 5s. I apologize for that. Should have been quiz 6, but anyway, so it was asking for % yield on your quiz, and so same thing here. And so we just want to take our actual, right? So this was from our problem. So if we recovered 36.7 grams of iodine, and we already calculated our theoretical yield. So again, this is our theoretical yield. And so then you find your % yield. So what did your % yield come out to? So 76.9%, and chat also got that. And so, right, you're not comparing it to a standard value. So, right, you're not taking your actual minus your what you found over the actual, right? You're not comparing it to a standard. You're just finding % yield. So don't confuse those situations. That looks good. All right, we'll try another Hess's Law question since people want to practice that. So this should work out. So try this one. So again, I would expect something like this on your exam where it's going to be symbolic in nature. So we have A plus B gives us C with that change in enthalpy. C plus A gives us D. 2D plus gives us G plus 3A. And we're trying to get to this target below here. So we want to know the change in enthalpy for this reaction down here. So take a few minutes with it. See if you can figure out, again, how to add 1, 2, and 3 such that we get our target here. Sorry, I had the mic muted. Sorry, I was blabbing. I was trying not to have other sounds. So yeah, sorry, we multiplied the first equation times 2 along with the second one. Again, just basing it kind of off of these D's, just reiterating for the online folks since I wasn't watching my mute button. And so now we can add it up. So negative 120 times 2 plus 80 times 2 and then plus negative 200. And I believe chat has a correct answer of negative 280. Is that what everyone else got? So I see some nods. Excellent. So that was, again, these are always kind of tricky, so it was a little tricky one. And so hopefully that helps make people feel better about those types of questions.
Was there like a practice packet like last time?
No, I didn't have a nice fancy practice packet.
Practice
Yeah, there was the quiz on there. I don't know if you saw that there's supposed to be a practice quiz.
Okay.
And I may still try to post like a few practice problems, but yeah, I'll post some more stuff, but yeah, just looking at your exam, we've kind of gone over the types of questions. So if anyone has any last questions, let me know. I'm just looking at the exam. There'll probably, again, there's going to be some sort of stoichiometry question, and maybe written, right, kind of tricky. I'm not going to give you equations. There'll be a bond enthalpy one. They'll certainly be drawing out Lewis dot structures. There'll be a Hess's law, just like this one with variables. And then you'll have multiple choice questions. Don't forget about mass percentages, so stoichiometry. We didn't review any of those. Remember, the Q equals our mass times our specific heat times our change in temperature. So might see a bit of that. Polarity. Again, small amounts. What's polar? Just kind of identifying polar, non-polar molecules. We'll try to keep it simple.
Are you giving us that equation? Or do we just
I wasn't planning on. Let me see. It is actually given to you on the cover sheet. Yeah.
Okay.
I'm just kind of looking at the exam. There might be like comparing specific heats and heat changes with this. So right, again, just kind of recognizing that if it has a smaller specific heat, it's going to change more in temperature and vice versa.
Are you gonna do a problem where we have to find the final temperature? If they
Potentially, yeah. And then, yeah, electron configuration, don't forget about that. I don't think I asked about quantum numbers. But yeah, moles, all that sort of good stuff, solutions. And yeah, so I generally don't put the equations. I'll show. Maybe I will show the cover sheet. Oops. So this is what the cover sheet of the exam looks like. So I have those formulas included. So I try to put a few helpful ones, kind of the basic ones, the work. But again, right, as this is an open note exam, I would kind of have your cheat sheet with all the formulas that you know you're going to need on there. Maybe annotate your book, because like your book also has, right, at the end of every chapter, there's all those formulas. So I would almost like just come in with your book, have those tabs, right? That's like almost what you need. Just make sure, yeah, exactly. Just make sure you know how to use the formulas, right? Like that's the main thing in this class, is that can you apply the formulas to the correct situation? So, yeah.
On the stoichiometry questions, if you're not giving the balanced equation, are you still gonna give like the actual compounds of each individual energy or right?
Yeah, I'll just give the names, right? Like iron sulfide plus, silver nitrate, like that sort of thing. So yeah, it'll be tricky. Other questions? So yeah, that probably ends the official review, and then I am available, so let me know if you need anything or need to make up stuff. Otherwise, I will see you this afternoon for the lab final.
I will see you.
All right, I'll hang around on stream for another minute or two in case there are questions. And so again, I would have most of your equations written. I would not depend on me. And if you need to borrow a textbook, let me know sooner rather than later. Right now, I have my textbook. Yeah, for today. Yeah, and then if you're Thursday, you'll take it on Thursday.
Is there a lab today?
Lab final, yes.
What is that?
It's a lab final.
It's like written test, or we would do an actual lab?
There will be both.
Oh, okay.
I just have a question about this. I would never like the case questions and answer. I'm sure of that. I don't know how I did this. I think it was the one time that like you reprinted the test. You remember that?
Uh,
Are you sure I didn't turn a different one in?